Welcome to Basic Electrical Engineering. We're in lecture number 23. Today we'll study reactance and impedance. We are studying AC circuit analysis. Reactance and impedance, they are the terms we use to describe the opposition to the AC current flow by certain elements like inductors and capacitors and their combinations and resistors, of course. A reactance is an opposition and it can be caused by two circuit elements, inductors or capacitors. The reactance offered by an inductor is called inductive reactance and by a capacitor is called capacitive reactance. Inductive reactance XL is the opposition offered by an inductor, can be written as 2 pi times the frequency times the inductance L. There's omega L because 2 pi F can be written as omega, and the impedance offered by an inductor is J times omega L, where J is iota. In our earlier lectures, we have studied about iota. Iota is written as J for circuit analysis and is equal to the square root of -1. Capacitive reactance is 1 over 2 pi Fc, where 1 over 2 pi F is omega, so it can also be written as 1 over omega c, and the impedance offered by a capacitor is 1 over j omega c. Well, this 1 over j can also be written as minus j because we have studied in our earlier classes that 1 over j is a complex number, and if we it can also be written as, if you multiply it with j and then divide by j, so the fraction remains the same. It becomes j squared. Since j is square root of -1, squaring j results in -1. So this is j over -1. This is minus j. So 1 over j. We studied in our earlier classes in elementary school that 1 over j is minus j, or 1 over iota is minus iota. Right. So, and then an impedance can be a combination of a resistor, inductor, or a capacitor, or any of the two of these three quantities: resistor, inductor, and capacitor. Now we have an example to solve where we have a source, a resistor of value 1 ohms, an inductor of value 2.65 millihenry, and a source with sinusoidal signal 10 cos 377t plus 0 degrees. Right. 10 is the magnitude of the cos wave being applied as input. 377 is equal to 2 pi f, or omega times t plus it starts from 0 degrees. It has no lagging or leading behavior, so it's starting from 0 degrees. Right. So we need to find out the current through this series circuit. But before we find current, we have to write this in terms of phasor and this in terms of its impedance caused by an inductor. So first we have to compute inductive reactance and then ZL. Right. So let's start by analyzing this circuit. To find out I, we have to first write this input source as a phasor. Right. So the magnitude is 10 at an angle of 0 degrees. So this is our V. So the input voltage V is 10 at an angle of 0 degrees. Right. Now to compute XL and then ZL. XL is 2 pi f or omega. In other words, omega. What is omega? It's 377t. This 377 is our omega. So we put 377 here times 2.65 milli. This gives us an XL equal to 1 ohm, 0.99 ohms or 1 ohms. The next step is to find ZL. To find ZL, finding ZL is straightforward. J omega L, J1, 1 ohm. So now we have computed ZL and V. So we are all set to find the current through this circuit, because current I is V divided by CL. Oh, it's not CL, just we have a 1 ohm resistor plus CL. So the total C is this value of R plus CL. So the total resistance of the path is resistance offered by this 1 ohm resistor plus the opposition offered by this 2.65 millihenry inductor. So we have added these two terms together. The unit is ohms, the unit for ZL is also ohms. Right. So now we are in a very good position to find I. V is 10 at an angle of 0 divided by R, which is 1 plus CL, which is J1. So now we have this numerator in polar form and denominator in rectangular form. This is polar form. It's a complex number represented in polar form. This is also a rectangular. This is also a complex number but represented in rectangular form. We have already studied that to divide two numbers, they both have to be in polar form to make the calculation easier. Right. So this is 10 at an angle of 0. So let's convert this into a polar form. For polar form, R is, we have already studied square root of x squared plus y squared. We have x as 1, y as 1. 1 squared plus 1 squared. Square root of 2. So and theta is tan inverse y over x. Tan inverse 1 over 1. So tan inverse 1 is the theta for which sine and cos are equal, is 45 degrees. So square root of 2, an angle of 45 degrees. So if we divide two polar numbers, the magnitudes are divided and thetas, the angles are added. So subtracted 0 minus 45 degrees. So our I comes out to be 10 over square root of 2 at an angle of minus 45 degrees. What does this minus 45 degrees tell us? It tells that the current in an inductive circuit is lagging behind the the applied voltage. Right? And we can very easily establish that for a series RC circuit, current would be leading the applied voltage. In the lectures to come, we'll study more circuits related to ACs, and we'll apply basic theorems like KVL, KCL, nodal analysis, and loop analysis for AC circuits. Thank you.